Now we are discussing the optimal approach. I wanted to return the suboptimal code at the right side of the page such that I wanted to show you how the suboptimal code is being modified with the optimizer code as we discuss the optimizer approach algorithm as we prolong in this lecture. So what's my intention was I don't want even this S pointer. So all I was doing was I wanted to tackle with the end pointer itself, not even with the start pointer. However, I'll be taking the variables which is of summation and which is of maximum value. So that's the thing we have to find out in these things. So and my observation is whenever you've been standing at this point itself, so every array is being sliced to a subarray and the slice portion is of up to E section itself and you are not sure about what it might be the starting point and from E plus 1 to the end of the array is the remaining portion of the slice. So let me just take 0 as the starting point. So let me show you the optimal approach. So in the optimal approach, what I feel was instead of using two pointers, which is of starting pointer and the ending pointer for generating the subarrays and calculating the summation along by generating the endpoint mode itself. Instead of taking as two pointers, we can only use the end pointer itself. And I wantedly return the suboptimal code at the right hand side of this page. The modified version of the suboptimal code itself is optimal code. Now coming to the lectures. As we discussed, like the end pointer is been stating here, and I was still considering the summation and the maximum things which has been taken in the suboptimal case. Here, the end pointer itself is been dividing my entire array into two slices. That is, slice 1 is nothing but from 0 to up to the endpoint, and slice 2 is nothing but endpoint plus 1 to the length of the array. Let's take n minus 1 to be precise. So this is how the array is been doing off. And whenever I'm just iterating my endpoint, it is like you're just adding you're just removing the first element from the right hand of the slice and you're just adding that element into the left hand of that slice. So this is what actually happening while iterating through the endpoint. If we consider an array in a form of a two slices, one slice is up to the endpoint and the second slice is from the next element to the last element of the endpoint. Now, what our intention is, since we are already having a slice and you just wanted to encounter a new element into that slice such that our main intention was to maximize the things. So if the new element is been added to the slice, then eventually the slice is been increasing to array of e plus 1. Now my question is whether you can find the maximum with the array of e plus 1 itself or with the array of 0 to e plus 1 subarray slice. So for the answer for that one is if the summation of this particular slice a positive value, then adding a one more element to this slice will eventually helps this subarray either it may increase or it may decrease. But however, comparing to the any of the incoming value, this subarray will be always higher if this value is been positive. Why I am saying like that? Because let's take this as minus 5 itself, and this is a positive subarray. Any positive number that is been added for the minus 5 will be eventually greater than minus 5 itself. So that's my intention. If it's been positive, try to include the incoming element itself. What if this is a 0? So if the slice value itself has been 0 and the incoming element is minus 5, then eventually the summation of the upcoming slice is also minus 5 itself. Or considering the individual element itself, array of e plus 1, this is also minus 5 itself. So instead of taking the entire slice of e plus 1, you can make it as e, and you can start with a new array slices. So it would be good if you don't consider this one. Now coming to the negative case. If this slice itself is been negative, whatever the input number it may be, whether it may be negative 5 or it may be a positive 6, because of this slice is being added with the negative number, then eventually this slice itself is being responsible in dragging the value. So the new value, which is of array of 0 to e plus 1, the slice itself is being responsible in dragging the value of array of e plus 1 to down. So in such kind of scenarios, it will be good if you don't consider this slice. So there will be two cases where you would be good if you don't consider this slice. So one was if the slice itself has been a negative case, and if the slice itself has been turning to 0, then it will be good if you don't consider this slice. If the slice has been contributing to any sort of positive value, it will be always beneficial compared to any kind of individual values. Then eventually, if you drop this slice from 0 to e and the incoming element is of e plus 1, however, there exists the remaining portion of the arrays also. Assuming you are just standing at this position, and let us assume initially you have not dropped any of the slice, or else let me just change the value numbers here. So initially it is been 1, 2, and this is of minus 5. So you're just standing at this position itself. Up to this position, the slice is been of negative, which is of 1 plus 2 followed by minus 5, which is of 3 minus 5, which is minus 2. And at this position, the upcoming element is of 4. So if you are considering the previous negative element itself, the negative element itself is been responsible in dragging the value of the 4. So instead of like that, it would be good if you can ignore this slice, and if you start exploring from e plus 1 to the end, and if you wanted to get some other slice, as I said, any array can be reduced in the form of a slice 1 plus slice 2. If you are neglecting the slice 1, then you start iterating from the slice 2 itself. So this slice 2 itself will behave like a new array or a subarray. And so this is the theme here. When you start getting a negative element, you'll just ignore that slice. And the remaining portion of the slice itself will start behaving like a new array. So in this case, you'll be ignoring this portion. Let me just eliminate this portion. So there's no point of considering -2. So we just eliminated this slice, and so your new array itself is this region. Then eventually the slice has been ignored and you're just resetting the summation to the 0, and you start exploring your new array which has been starting at third index to E. So in this region only you'll start getting a new slice, and the other slice of the array is as usual E plus 1 to the last element of that array. So now this is the same suboptimal code which has been placed at the right side. As I said, we are just taking only one pointer which is of end pointer, so there is no need of having any kind of start pointer. So I'm just deleting this portion of the code. And but I also mentioned you, we are just considering the sum variable followed by the maxi variable. So we're just including this one. So taking the sum value as 0, and I wanted to iterate the end pointer from the starting to the last element of the array. So this iteration will be there. And here we are not focusing on any kind of subarrays, because when we are deleting the first part of the slices or something like that, then eventually our next part of the array will be of n plus 1 to the end, something like that. So at every end position, we will be calculating the summation. And if the summation has been calculated, eventually we will be finding the maximum up to that slice. And now here comes the dry run when the endpoint is when summation is equals to 1. So you just move to the forward position, and here let me just say, here still the code has not been constructed. Up to this point the code is been actively constructed from the suboptimal things. We have not encountered edge case, which is like when the previous slice itself has been negative. So since the sum has been 1, the max has been 1, and again the end pointer has been reached to the second element, which is of first index. Now sum, the previous slice sum has been added to the current element, so the sum will be 3 and the maxi is been updated to 3. Now the end pointer is being moved forward. Now you just encountered an element which is of -5. So here comes the thing, your summation is been going to the negative. If your summation is been going to the negative, then the slice which you have been working through till now is been actively reducing the incoming values which has been added to this slice. So there is no point of picking up this slice, and you just wanted to go through a new form of an array itself. That is, this portion itself will be acting like a new array. Since you just wanted to act it like a new array and you wanted to drop this slice, at this step itself mark the summation as 0. That is, this is the code. When you just encountered a summation which is of negative, then there is no need of storing the summation up to that slice. So just mark that summation as 0, which is in other words, you just dropped the slice up to which the end pointer is there. And again, you are freshly starting iterating through an array, which is nothing but you just dropped this slice and you move forward with your end pointer. Because you just dropped that slice, your summation will be reset to 0. But however, you have not dropped the max value because maybe whatever the value have been encountered in the previous slice, that might be the maximum value if you don't encounter any value that is been greater than that summation. So resetting this summation itself is the thing. And when you encounter this one, this itself is a new array. So your summation will be of 4, and now you just make a max of 4. And moving forward, your summation will be 3. So the max is 4 itself. Moving forward, your summation is been increased to 5. Now the max value is 5. And moving forward, you just increase the summation to 6. So the max value is of 6. Moving forward, you just made the summation to 1, but still the max value is 6. Moving forward, you just made the summation to 5, still the max value is 6. So that is how you can able to improve the code. And by the way, after finishing the loop, you have to return the maximum value that you found while you have been traversing the entire loop in a single time. So this optimal approach is also known as a Kadani's algorithm. So this is the Kadani's algorithm. And time complexity for this Kadani's algorithm is, as you know, we just iterated through the entire array itself. So the time complexity for the Kadani's algorithm is O of n. That's it. So we just started with a time complexity of O of n cube, reduce it to O of n square, and we just made it to solve it in O of n to find the maximum subarray sum. So that's it for this video. Thanks for watching.